This is a video walkthrough of the solutions to the review for Unit 2. The Part 1 of the review is without calculator, and our first question asks why tangent inverse of 6/5 has a value while cosine inverse of 6/5 is undefined. So what we need to understand here is that each expression represents an angle. Let's let angle A equal the tangent inverse of 6/5, which means tangent of angle A is equal to 6/5. The ratio of opposite to adjacent can be greater than 1 because the opposite side in a right triangle can be greater than the adjacent side. Let B equal the cosine inverse of 6/5. So cosine of angle B is equal to 6/5. There is no angle where adjacent to hypotenuse is larger than 1, and that is because the adjacent side cannot be larger than the hypotenuse. No room to write that there. All right, let's start with 2 through 5 now. Without using a calculator, we're going to solve each equation for each side or each angle. We may assume that all angle measures are between 0 and 180 degrees, and when appropriate, we're going to leave our answers in radical form. So we're not going to get an approximate answer because we don't have a calculator. All right, so in number 2, I'm going to start by cross-multiplying this proportion. So P times the sine of 45 degrees is equal to 8 times the sine of 60 degrees. The sine of 45 degrees is the square root of 2 divided by 2, and the sine of 60 degrees is the square root of 3 divided by 2. I'm going to skip the part where we make diagrams of these. I'm assuming that you can do that on your own since that was covered in Unit 1. All right, so let's simplify each side. P times the square root of 2 divided by 2 is equal to 4 times the square root of 3. Now what I'll want to do is clear my fraction by multiplying both sides by 2, and then we're going to divide by the square root of 2, and then we're going to rationalize that final answer. So we have the solution, right? But we want it in rationalized form. That is, the denominator needs to be a whole number. So P is equal to 8 times the square root of 6 divided by the square root of 4, which is 8 times the square root of 6 divided by 2, or 4 times the square root of 6 is the value of P, which is the length of a side in this proportion. All right, let's check out number 3. In this, we're solving for angle P's measure. So we're solving for an angle, but we're going to follow the same procedure here. So we've got cross-multiplying the square root of 3 times the sine of angle P is equal to the square root of 2 times the sine of 120 degrees. And we can go ahead and find the sine of 120 degrees. The sine of 120 degrees is, let's see, that's going to be the square root of 3 divided by 2. And so from here we can simplify each side. and that will give us the square root of 6 divided by 2 when we multiply those two fractions together. And for our next step, when we solve for sine of angle P, I would encourage you to think of this as dividing, instead of dividing by the square root of 3, multiply by 1 divided by the square root of 3, or 1 over the square root of 3. Remember, division is the same as multiplying by the reciprocal. We can reduce now because we have two factors which are both square roots, and the square root of 6, remember, was the square root of 2 times the square root of 3. So now we have the sine of angle P is equal to the square root of 2 over 2. It may be in our better interest to think of this in unrationalized form. So now I'm going to draw a picture. When sine is 1 divided by the square root of 2, that gives us a 45-degree reference angle in quadrant 1. But remember, sine is ambiguous. The sine of the supplementary angle in quadrant 2 gives us the same result. So that supplementary angle is 135 degrees. So the measure of angle P can be either 45 degrees, an acute angle, or 135 degrees, an obtuse angle. All right, now let's take a look at one that involves the law of cosines, or the law of cosines has already been set up for us. P squared is equal to 25 plus 12 minus 10 root 3 times cosine of 150. So P squared is equal to, let's simplify some terms here, 37 minus 10 times the square root of 3 times the cosine of 150 degrees. And the cosine of 150 degrees is a negative number, and that negative number is negative square root of 3 divided by 2. Remember, cosine is negative for obtuse angles. And now let's do some multiplication here. The last two terms in this expression on the right side of the equation are both negative, or rather the last two factors are negative. So when we multiply them, we'll get a positive number. So 37 plus, and then we have 10 times the square root of 9 divided by 2. So P squared is equal to 37 plus 30 divided by 2 is 15. And P squared is equal to 52, and P is the square root of 52, so that will be 2 times the square root of 13 in simplified radical form. Okay, let's move on to number 5, and this is a law of cosines type of a setup, but this time we're solving for the angle. So the process is going to be a little bit different. Let's simplify what we've got on the right side of the equation. 1 plus 25, that can be added to get a result of 26, and we cannot subtract that 10 there because the 10 is multiplying the cosine of angle P. So in order to solve, we've got to subtract 26 from both sides. That leaves us 5 equals negative 10 times the cosine of angle P. Let's divide through by negative 10. 5 divided by negative 10 is negative 1/2. So negative 1/2 equals the cosine of angle P. And let's remember that cosine is not ambiguous when we are solving for an angle between 0 and 180 degrees. That means we can only find one solution in that range of values. If cosine is negative 1/2, that means adjacent divided by hypotenuse is negative 1/2. And that will give us a 60-degree reference angle. That means the angle in question is 120 degrees. So measure of angle P is 120 degrees. Only one solution between 0 and 180 degrees. All right, let's move on to the calculated required portion. So in this, we are going to find the measure of the smallest angle in a 3, 4, 5 right triangle, and we're going to round our result to the nearest thousandth of a degree. First, I'll want to draw a picture of a 3, 4, 5 right triangle, and I'll want to make sure that my triangle has somewhat of a scale to it, so 3 should look like the shortest side. That will make it much easier to identify that shortest or smallest angle. So let's call that value x. So take your pick of any trig ratio, doesn't matter which one you pick. So I'm just going to pick sine. Sine of x degrees is equal to the opposite over the hypotenuse. And we solve that with a calculator by finding the inverse sine. So x is equal to the inverse sine of 3/5. And now we're ready for a calculator. So the inverse sine of 3/5 is equal to 36.870. And that will be measured in degrees. It's okay if you leave the degree measure off, because sometimes that can be confused with 0. And so up to you whether you want to include that or not. All right, we're going to find the area in number 7 of this triangle and round the answer to the nearest thousandth. Hint, draw in the height of the triangle. So I'm going to draw in the height, and the height splits that 13 into two pieces, not equal. But what we can notice is that we do have a right triangle over here on the left side. My highlighter's not working so well. Yes, so we're just going to consider that highlighted triangle. And so for that highlighted right triangle, we can use SOHCAHTOA. So that means that the sine of 28 degrees is equal to h divided by 8. That's opposite over hypotenuse. So that means that the height is 8 times the sine of 28 degrees. Let's leave that in exact form since it's not a final answer. The area of this big triangle is 1/2 times the base times the height, and the base of the triangle is 13, and the height is 8 times the sine of 28 degrees. 1/2 times 8 is 4, times 13 is 52. So in exact form, 52 times the sine of 28 degrees is the area of the triangle. Now we're ready for a calculator. 52 times the sine of 28 degrees is 24.413. We don't have to put any units on this area. It would be measured in square units, but since the lengths don't have any units attached to them, we don't need to give units on the area. Okay, let's move on to questions 8 through 14, which are solving triangles. In solving triangles, we're going to be given 3 parts of the triangle, and those 3 parts of the triangle will be angles and sides. And then we'll identify the pattern of givens, solve the triangle. When appropriate, we're going to state that there is no solution, or find 2 solutions when appropriate. And we're solving for the remaining sides and angles. Okay, remember to store intermediate results to ensure your accuracy. So in 8, we have triangle MTA. I'm going to draw a picture of that and label the vertices, and then the given information. Angle M's measures 25 degrees, the side opposite angle T measures 10, and the side opposite angle A measures 17. This isn't a side angle side or an SAS pattern of givens. In that case, we're going to be using the law of cosines, and when we use the law of cosines, that involves 3 sides and an angle, so M, the unknown side, will be one of the things that we solve for, and that'll be the first thing. So m squared is equal to 10 squared plus 17 squared minus 2 times 10 times 17 times the cosine of the angle opposite m, which is 25 degrees. In order to solve for m, we need to take the square root of both sides. M is equal to 10 squared plus 17 squared minus 2 times 10 times 17 times the cosine of 25 degrees. Now it's time to let the calculator do that for us. Control and x squared will get us a square root. Right? We don't have to do any of this intermediate arithmetic. Just enter in everything as you see it. 10 squared plus 17 squared minus 2 times 10 times 17, and you can enter the times sign between the 17 and the cosine if you wish, but it's not necessary. I've mistyped. check your typing as you go. It's easy to mistype. Okay, and that's going to give us an M value of 8.992. That's important to realize. That's not the exact value. When we do the next calculation using this, we're going to have to store this intermediate result. So I'm going to go ahead and include that in the triangles diagram here, insert that answer, and now we have two remaining angles to find. When we are finding remaining angles, it's very important that we start with the smaller of the two angles. Angle A is the largest angle because it's opposite 17, the largest side. So when we start to find a remaining angle, we should start with angle T. So I'm going to use the law of sines. Sine of angle T divided by the opposite side 10 is equal to sine of 25 degrees divided by 8.992. Now let's cross multiply. 8.992 times the sine of angle T is 10 times the sine of 25 degrees, and dividing by 8.992, sine of T is 10 times the sine of 25 divided by 8.992. From here we can find the measure of angle T by taking the inverse sine. Now remember, we talked about sine being ambiguous. That is, when I enter the inverse sine into my calculator, it's going to give me an acute angle. That's why we have to be careful. We have to ensure the angle we're solving for is actually acute. So there's only one obtuse angle possible in a triangle, and if there were an obtuse angle, it would be angle A since it's opposite the largest side. So measure of angle T equals, now let's do that calculation. That would be inverse sine. So I'll need my trig menu there. Inverse sine, use control divide for a fraction. 10 times the sine of 25 degrees divided by, and here instead of using the number 8.992, I'm going to use the answer from the calculator that's more accurate, or I'm going to use the answer feature. Notice that when I do that calculation, it's bringing all the extra digits of the unrounded value, and that gives us 28.034 degrees. So now that we have that angle, angle T, I'll add that to the diagram. 28.034 degrees, and we have one angle to solve for that's left, and the easiest way to solve for the remaining angle is to subtract the angles that we already know from 180. 180 minus 25 minus 28.034, and now I'll just let the calculator do that calculation. Even though this is a final answer, we don't have any calculations left to do, I'm still going to use the answer feature just for accuracy. 126.966 is measure of angle A. What was that? 966. I'm going to take some time and put that in my diagram. 126.966, and then just investigate my answer for reasonableness. Our largest angle, the obtuse one that we just found, is opposite the largest side, and our smallest angle, 25 degrees, is opposite the smallest side, 8.992. This answer seems reasonable. All right, moving on to number 9. We have triangle PUN, which I'll picture and label the parts. Angle P's measure is 49 degrees, angle U's is 70 degrees, and the side opposite angle N measures 13 units long. This is an angle side angle situation. Pattern of givens, that means that we're going to use the law of sines to find remaining parts. However, we want to start with the easiest thing to find first, and that would be the measure of the third angle, angle N, which is 180 degrees minus 70 degrees minus 49 degrees. And that number is 61 degrees. Now that we've found that number, I'm going to include that in our label. Now we have all three angles. The only remaining parts to find are sides. There's no ambiguity about finding sides in the same way that there is finding angles using the law of sines. So we just set up two proportions. It doesn't matter which side we solve for first. So sine of 49 degrees divided by the opposite side, which we'll call P since that's opposite angle P, is equal to the sine of 61 degrees divided by the measure of the opposite side, which is 13. Cross multiplying, P times the sine of 61 degrees is equal to 13 times the sine of 49 degrees, and P is 13 times the sine of 49 divided by sine of 61. Now we're calculator ready. Control divide for a fraction. 13 sine of 49 divided by sine of 61 is equal to 11.218. Now that we have that side length, I'll label the side opposite angle P 11.218, and we're going to find the remaining side length using the law of sines also. Sine of 70 degrees divided by the opposite side length, which we'll call U, is equal to the sine of 61 degrees divided by 13. Cross multiplying, U times the sine of 61 is equal to 13 times the sine of 70. So U is equal to 13 times the sine of 70 divided by the sine of 61. We can edit the previous calculation that we've done and change that 49 degrees to a 70 degrees, and side U's measure is 13.967. Since we now have our last piece of the triangle, I'll go ahead and complete the diagram with that measure. We'll notice that 13.967 is the largest side, and it's opposite the largest angle, which is 70 degrees. Our smallest side, 11.218, is opposite the smallest angle, 49 degrees. In number 10, we have a triangle RAD, which I'll draw here. And angle R is 37 degrees. The side opposite angle A measures 8, and the side opposite side R measures 7. This is an SSA pattern of givens. That means we're going to use the law of sines, but that we might get more than one solution. We also might get 0 solutions. We just don't know until we start. All right, so law of sines involves two angles and two sides. So the missing angle, considering the pairs of opposites that we have, is angle A. So when we set this up, the sine of angle A divided by 8 is equal to the sine of 37 degrees divided by 7. Cross multiplying, 7 times the sine of A is equal to 8 times the sine of 37 degrees. And we're going to divide by 7 and then take the inverse sine. So the measure of angle A is equal to the inverse sine. And I need to be prepared for two solutions. So I'm going to move this over to this side. Measure of angle A is equal to the inverse sine of 8 times the sine of 37 degrees divided by 7. What we have to remember is that inverse sine will give us an acute angle when we put it in the calculator, and when sine is a positive number, then there are two solutions between 0 and 180 that are valid. The calculator is only going to give us one of those. So to find that value, sine inverse of control divide 8 times the sine of 37 degrees divided by 7, and enter. That'll give us 43.455. What we need to remember is that when we're solving an angle for, when we're solving a proportion for an angle, and we find the one value that the calculator gave us, that there's a second solution that is the supplement of the first. So the second solution would be measure of angle A is equal to 180 degrees minus the 43.455. I'm going to hang on to that calculation. That's where we're going to start our second solution. So this first column on the left will be for the first solution, and that second column will be for our second solution. Let's go ahead and label what we now know to be part of the first solution. That measure of angle A is 43.455. And let's find immediately the third angle. Since we already have two angles, the easiest thing to find next is the measure of angle D, which is 180 minus 37 minus 43.455. So measure of angle D is equal to and as I'm entering this, I want to be careful to use the answer feature for the 43.455 because we want our next answer to also be accurate beyond 3 decimal places. So measure of angle D is 99.545. And now that I have that measure, I'm going to go ahead and record that in the diagram. And now there is one side that remains to be found. In order to find that side, we'll set up a proportion using the law of sines. And that missing side is the side opposite angle D, so we're going to involve angle D here. The sine of 99.545 divided by the side opposite angle D is equal to, and I'm just going to use something that we don't have to worry about an approximate value for the other side of the proportion. So sine of 37 over its opposite side, 7. Now let's cross multiply. And if we cross multiply and divide, D is equal to 7 times the sine of 99.545 divided by sine of 37. And that can give us our approximate value. Control divide for a fraction, 7 times the sine of, and this is an approximate value, so I want to make sure to use the answer feature here, divided by the sine of 37 degrees, and that side measures 11.470. Now that we have that third side, I'm going to label it in the diagram 11.470, and I'm going to investigate to make sure that our largest side, which is the one we just found, is opposite the largest angle, 99.545, and our smallest side, 7, is opposite the smallest angle, R, which is 37 degrees. Answer seems to make sense. Let's go back over to our second solution. Whenever we have an SSA case, we have to remember that we may have a second solution. I'm going to recopy the diagram of triangle RAD and put the given information in. And then the angle A, which is the first thing that we'll find in the triangle, will be, in this case, the supplement of the angle A that we found in the first solution. So I'm going to start by calculating that angle, which is 180 minus the 43.455. That's a rounded value, so I'm going to go up and I'm going to grab that calculation from a previous one and then find that value. 136.545. And that's the first measure in the second solution. Since we have that, I'll label that in the diagram 136.545. And then the easiest thing to find next is the third angle. If the third angle turns out to be negative, there will be no second solution. But if the third angle turns out to be a positive number, then we will, in fact, have a full second solution. So the measure of angle D remains to be found. That is 180 degrees minus the 37 minus the 136.545 that we just found. And I'm going to be sure to use the answer feature to take that with all of the decimal places that belong with it for our next calculation. So measure of angle D is 6.455. Since I have that result, I'll go ahead and include that in the diagram, 6.455 degrees. And then we have one thing that remains to be found, and that's the missing side, which can be found using the law of sines. So, using the law of sines, we can set up a proportion. The sine of 6.455 divided by the length of the opposite side, which we should call D, is equal to the sine of 37 degrees divided by the opposite side, 7. Let's cross multiply and divide. That will give us D is equal to 7 times the sine of 6.455 divided by the sine of 37 degrees. And then we can find a 3 decimal place approximation for that value. So control divide, 7 times the sine of 6.455, which is a rounded value, so I'm going to use the answer feature to enter it, divided by the sine of 37 degrees. And that gives us 1.308. Make sure to box your answers, and I'm going to do one last thing to check my result. I'm going to include that in our diagram for the second solution, 1.308. And so if you want to, you can box in the first solution and you can box in the second solution to indicate that there are two different solutions. Let's just take a look at our triangle for the second solution. The smallest angle, 6.455, is opposite the smallest side, 1.308. The largest angle, 136.545, is opposite the largest side, 8. Now let's look at number 11, triangle, meh. And in this triangle, the side opposite angle M is 7, side opposite angle E is 9, and the side opposite angle H is 13. This is a side-side-side pattern of givens. That means we're going to have to use the law of cosines to find a missing angle. Doesn't matter which angle you find first. So I'm just going to find the measure of angle E. So in order to do that, I'm going to have E squared by itself on one side of the law of cosines. 9 squared is equal to 13 squared plus 7 squared minus 2 times 13 times 7 times the cosine, because it is the law of cosine, of angle E. We're going to have to do a little arithmetic, and you can use your calculator to help if you want. And this will give us 14 times 13. I'm going to grab the calculator for that calculation. 2 times 13 times 7. Help if I type it right. Is 182. So 81 is equal to 218 minus 182 cosine of angle E. Be careful that you don't subtract 218 minus 182 because the 182 needs to multiply cosine of angle E. So we'll have to solve by subtracting 218 from both sides. 81 minus 218 is negative 137. So negative 137 is equal to negative 182 times the cosine of angle E, and so that means that angle E has a cosine equal to positive 137 over 182, and that means that the measure of angle E is equal to the cosine inverse of that value. Cosine is not ambiguous, so measure of angle E is definitely whatever the calculator tells us it is. So control, let's see, not control. We are actually going to use the inverse sine, inverse cosine of 137 divided by 182. That's 41.171 degrees. Since I have that value, I'm going to go ahead and insert that in the diagram. And now we can move on to the other angles that we need to find. Here's where we have to be very careful. Of the remaining angles, angle H is opposite the longest side 13, so it is possibly obtuse. If we choose to use the law of sines to find a remaining angle, it's important that we choose an angle that must be acute. So angle M definitely must be acute, since there can only be one obtuse angle in a triangle. So let's set up the law of sines to find that missing angle. Sine of angle M divided by 7 is equal to the sine of 41.171 divided by 9. So multiplying by 7, sine of angle M is 7 times the sine of 41.171 divided by 9. And that means the measure of angle M is the inverse sine of that expression. And the measure of angle M is equal to and I wrote that wrong, that's the sine inverse there. So whenever we're finding an angle, we'll always find it using the sine inverse of control divide 7 times the sine of, and here's where we want to be careful about the accuracy, use control answer to bring the previous angle that we just found as the number to be used in the calculation divided by 9. Enter, that's 30.798. Now that we have that result, I'm going to include that in our diagram, 30.798. And now it should be obvious that the easiest thing to find next is that third angle just by subtracting from 180. So the measure of angle H is equal to 180 minus the 30.798 minus the 41.171. Even though this is a final answer, I'm still going to use the answer feature to make sure that we get accuracy beyond the rounding places that are specified. So 180 minus the 30.798, I'm just going to grab that calculation, and then minus the 41.171, and press enter, and we get 108.031. Notice that we get an obtuse angle. Had we used the law of sines to find that angle, the calculator would have given us an erroneous result. So when we're done here, let's insert that value in our diagram. That was 108.031. And as expected, the largest side, 13, is opposite that angle. Our smallest angle, angle M, has the smallest side opposite it. So our answer makes sense. Moving to number 12, triangle CUD with measure of angle C 20 degrees. The side opposite angle C is 7 and measure of angle U is 132 degrees. This is an angle side pattern of givens. Whenever you have two angles given, the easiest thing to do is to find that third angle first. So measure of angle D is 180 minus 20 minus 132. And that gives us 28 degrees. Since I now have that angle, I'm going to insert it in the diagram. And now we get to find the remaining sides. It doesn't matter which side we find first once we have all the angles, because the law of sines doesn't give us ambiguous results when finding sides, only when finding angles. So to find a remaining side, sine of 132 divided by the opposite side, which we'll call u, is equal to the sine of 20 degrees divided by 7. Cross multiplying u times the sine of 20 degrees equals 7 times the sine of 132. And dividing u is 7 times the sine of 132 divided by the sine of 20 degrees. That's calculator ready. So let's grab the calculator to do that computation. Control divide for a fraction. 7 times the sine of 132 divided by the sine of 20 degrees equals 15.210. Now that we have that side, I'm going to insert that in our diagram. And what remains to be found is the third side. We can do a very similar calculation for it. The sine of 28 degrees divided by the opposite side, which we should call d, is equal to the sine of 20 degrees over 7. And now cross multiply, d times the sine of 20 is equal to 7 times the sine of 28. And d is equal to 7 times the sine of 28 divided by the sine of 20. That's our exact form answer. And we can use the previous calculation to help with the entry here and just delete that 132 degree angle and replace it with 28. That will give us 9.609. I'll go ahead and insert that in the diagram. And let's make sense of that. That largest angle, 132, is opposite the largest side, 15.210. Smallest angle, 20, is opposite the smallest side, 7. In number 13, this triangle's bad. So, triangle BAD with angle B measuring 20 degrees, the side opposite measuring 18, and the side opposite angle D measuring 11. This is an SSA. That means that's possibly an ambiguous case. That means there might be 0, 1, or 2 solutions. So, what we need to do is set up the law of sines, because law of sines involves two pairs of opposite sides and angles. The angle in question will be angle D. And as we set that up, the sine of angle D divided by 11 is equal to the sine of 20 degrees divided by 18. So 18 times the sine of angle D is equal to 11 times the sine of 20 degrees. We're going to divide both sides by 18 and take the inverse sine. So measure of angle D is the inverse sine of 11 times the sine of 20 degrees divided by 18. And this is where we need to realize that in the SSA case, when finding an angle, that the law of sines may give us only one result where there might be two. So I'm going to make two columns. in our first column, the measure of angle D is equal to the acute angle that the calculator will now give us. So let's enter that calculation. And it's the sine inverse of control divide for a fraction, 11 times the sine of 20 degrees divided by 18. And that gives us an acute angle 12.064. Let's remember that an alternate solution could be that measure of angle D is equal to 180 minus that 12.064. When we use the law of sines, there are two solutions on the interval from 0 to 180, and the second solution is the supplement of the first. All right, let's just go with the first solution, and then we'll come back to that second solution later. So angle D in the first solution measures 12.064. And the easiest thing to find next is that third angle. So the measure of the third angle, measure of angle A, is 180 minus 20 minus the 12.064. So measure of angle A is equal to 180 minus 20 minus, and I'll use the answer feature to ensure the accuracy of any subsequent calculations that we make, and that's 147.936. Box in my answer, and I'll include that in our diagram, 147.936. Notice that's a really big angle. We're expecting the largest side, A, to be opposite it. So from here, in order to find the missing side, which is our third part of the triangle that needs to be found, the sine of 147.936 divided by the side opposite, angle A, which we'll call lowercase a, is equal to the sine of 20 degrees divided by 18, the opposite side. Okay, I'm going to cross multiply and divide at the same time, and side A is 18 times the sine of 147.936 divided by sine of 20. So A is equal to, control divide for a fraction, 18 times the sine of 147.936. This is an approximate value, so I'll use the answer feature to enter it, divided by the sine of 20, and that gives us 27.939. Which, when we look at the diagram, is indeed the largest of the sides that are indicated there. So that makes sense that it's opposite the largest angle, 147.936. Notice that the smallest side, 11, is opposite the smallest angle, D, which is 12.064 degrees. Okay, that ends solution 1. Now we need to go back to solution 2. SSA, we always need to look for that possible solution 2. And solution 2's first angle that needs to be found there has already partially been found. It's the supplement of the angle in the first solution. So I'm going to redraw triangle BAD over here to reference our second solution and put in the given information, and then make that calculation for the supplement of the angle D that we found in the first solution. So 180 minus, and I'm going to go grab that 12.064 from a previous calculation so that we bring all the decimal places with us, and measure of angle D is 167.936. Since we now have that result, I'm going to go ahead and insert it into the diagram. And perhaps you might see something here, but I'm going to go ahead and be very explicit about what happens next. Now that we have two angles, it's easiest to find the remaining angle, and measure of angle A is 180 minus 20 minus 167.936. And let's find out what that result is. 180 minus 20 minus, and that would be the previous answer. And that gives us measure of angle A is negative 7.936. And that's a negative result, so that can't possibly be. So what I'm going to indicate here is there must be no second solution. So we arrived at a contradiction. That second solution can't actually work. So this triangle only has one solution, but we need to see the analysis that leads to the conclusion that there is no second solution. For number 14, triangle is appropriately called NAP because that's what I'm going to take when I'm finished with this video. NAP has side N, or the side opposite angle N is 8, side opposite angle A is 7, and the side opposite angle P is 17. So we're going to use the law of cosines since this is a side, 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 and it doesn't matter what angle we find first, so let's find angle N. If we use angle N, then we've got to have 8 squared by itself on one side of the law of cosines. So 8 squared equals 17 squared plus 7 squared minus 2 times 17 times 7 times the cosine of angle N. And we'll have to do a little bit of arithmetic here. You can use your calculator certainly for these. And 2 times 17 times 7 is 238. I'm going to do a little bit of cleaning up. 64 is equal to, what's 289 plus 49? That's going to be 338. And what's important is that we do not subtract that 238. I'm just going to bring that term on down because 238 is multiplying the cosine of angle N. So all we can do at this point is subtract the 338. So 64 minus 338 is equal to negative 274. And now I'm going to correct a typo. I brought down that step before. It was negative 238. Should have been negative 238 times the cosine of angle N. So when we subtract off 338, we get negative 274, and that equals negative 238 times the cosine of angle N. Let's divide. 274 divided by 238 is equal to the cosine of angle N. So the measure of angle N is equal to the cosine inverse of 274 divided by 238. Entering that, remember that we're using the cosine inverse this time. And this says non-real calculation, which just means undefined. It's not going to give us a result. You might get different results depending upon what calculation you try to do, but undefined, non-real calculation, they're all indicating the same thing, which is that there is no such angle N that has this cosine value. So we get an undefined result, and so what does that mean? This triangle is not possible, so there is no solution to this triangle. What we'll notice is that cosine was a larger value over a smaller value, which can never be possible because the adjacent leg of a right triangle must always be smaller than the hypotenuse. And our exception to that is quadrantal angles where they have the exact same length, but the adjacent leg can never be larger than the hypotenuse for sure. All right, and that's all we need to do once we result in undefined angle measure. We abandon this solution entirely. All right, one computation left to do, and it's important to know that for this exercise right here, we only have to find the measure of the length that's indicated with the variable a. You don't have to completely solve the triangle. So I'm going to start with this smaller triangle over here, and I'm going to find some missing pieces here. Let's blow up this diagram. One of the things that we can observe here is that we have to have supplementary angles here. So this is 143 degrees. And then in that triangle that I just outlined, there are 3 angles. Let's find the third angle, 180 minus 24 minus 143 equals 13 degrees. So that angle up there at the top is 13 degrees. Now within this triangle, we can set up the law of sines to find a missing side. Now we have to strategize which side we want to find. The easiest side to find that will lead me to another solution is the side that is shared by both of the 2 triangles in the picture. So let's write the law of sines and find the value of the length represented by x. Sine of 24 degrees divided by x is equal to the sine of 13 degrees divided by 10. Cross multiplying, x times the sine of 13 equals 10 times the sine of 24. And so x is equal to 10 times the sine of 24 divided by the sine of 13. Now we're ready for an approximate answer. Control divide, 10 times the sine of 24 divided by the sine of 13 gives us a result of 18.081. That's a preliminary result. We're not quite to the answer that we're looking for. Now let's take a look at the other triangle in the picture, which is this right triangle sitting right here. And when we have a right triangle, you can easily use SOHCAHTOA to find missing sides and angles. So if we use SOHCAHTOA and realize that we now have the value of x, which is 18.081, that we now have the hypotenuse of that triangle, and side A that we're looking for is the adjacent side. So that means we're going to use a cosine ratio. Cosine of 37 degrees is equal to A, the adjacent side, divided by 18.081. That means that A is 18.081 times the cosine of 37 degrees. Now we can enter that into the calculator for an approximate result. Remember that 18.081 is a rounded value, so use Control Answer and then multiply that by the cosine of 37. And now we have a result of 14.440. And that is the missing side. That concludes the video run-through of the review.